Taking another example here, if you are declaring any integer array like this, int roll number bracket is equals to new int 10. So what is going to happen? It will create 10 memory spaces adjacent to this. Okay. It will allocate it to roll number variable, and the index will be 0 to 9 for those spaces. Roll number of 0 is 6. Roll number of 1 is 0. If you are allocating it, so for example, if you're saying in your program roll number of 0 is 6, so what is going to happen in the background? 6 will be allocated to roll number of 0. So roll number of 0 is 6. Roll number of, if you are not allocating any value, it will be by default 0. But then if you're saying particularly roll number of 7 is 99, so that will be allocated 99, and then index is 7. 8 and 9, if you're keeping it blank, that's fine. Okay. So this is how um, these things, allocation of the values and index works. In this very same example, uh, these are all the integers. Can I do something like this? Let's understand. Can I say roll number of 3 is equals to, mm, let's say 76.8998. Can I do that? It's saying me error. It's saying me that type mismatch cannot convert from double to integer. So what it is saying, at the right hand side, you have a double value and you want to assign it to the integer places. Okay. Roll number is purely integer. You declared it like this. You have declared it integer. So all the values which you are going to put in those 10 boxes should be strictly integer. Okay. It's like this. But there is a way. So it's saying one quick fix available. So it will suggest you also, if you want to fix the problem, what you can do. So there are two ways. Either you make it all the array values as double, one option. Another way is typecast it. So we are learning a new thing today, which is typecasting. Wait, let me write it. Typecast. Typecast. So here, temporarily, not permanently, you can change it to int. So what we are doing is, the number is 76.98, but if you want to change it temporarily to integer, just so that we can put it in this array, it's possible, right? But then the question is whether this will be actually 76.98 or something else. So if I'll print this, let's see what will happen. It's printing me 76. It's not 76.98. Let's understand why it is happening. There is a double value, and you said that I want to convert it to integer. The straightforward rule with integer is it will not accept decimal points. So whatever is there after the decimal, it will discard. It will not do round off. You may be thinking 76.98 is near to 77. So it should, even if it is changing, it should change to 77. No, it's not like this. Straightforward rule. Anything which is double or float, and if you have decimal points obviously after this will be discarded, and whatever is there before the decimal point is 76 will be allocated to roll number of 3. Simple one. Okay, so this is called typecasting. We'll see the example of typecasting. So let's create another program. We'll keep on talking about the arrays. Arrays are not just like you can learn it today and everything is sorted out. You have to do your own programs. You have to understand in different ways how how the array we declare, how to fill the values, how to print the values, how to get the values, how to do some kind of arithmetic operation on those values, right? As of now, because we initiated a talk about this typecasting, it's better we will have a separate program about it. Okay. Typecast. Okay. Let's create a new program here. And we'll give it a name, new class, typecast demo 1. Now, let's understand that you have an integer value. Integer x is equals to 30. And then you have a double value, double y, just double y. We have just declared it, not initialized it. Can I say w is equals to x? Is it allowed? Simple thing. We have integer x is equals to 30. Fine. There is a integer variable x. 30 will be allocated to x. Fine. Then there is a double y. Fine. So y will be another box, 8 byte. I think it takes 8 byte. That's fine. And we are saying y is equals to x. There is no error. If I print x and y both, there is no error. It will print me. I'm not going to print it as of now, but I'm saying that there is no compile time error. In any lines, there is no error. Why there is no error? It should say me that there is a problem because the right hand side, which is integer, and I'm assigning it to double, right? So it should throw me error. It's not showing me. Why? Because x, there is a hierarchy basically. X, which is integer, can be put into double. It's possible. So through picture, we will understand what I'm saying. Okay. Let me store it somewhere. Hold on. So let's understand. We declare integer x. Fine. We put the 30 here. Then we declare double y. So let me write it properly. This was integer. Okay. This is double. Double. And this is y. Let's understand. X takes 4 bytes in the memory. Double takes 8 bytes in the memory. 8 bytes. So what Java says is you can put the smaller boxes into bigger boxes. It's possible. And in real life also it's possible. You can put smaller suitcase to the bigger suitcases, correct? Or the smaller vessels into the bigger vessel. Right? Anything, or a smaller bag into the bigger bag. It is all about what kind of data it is, because double is also numerical, integer is also numerical. Only difference is double may have, after the decimal point, it may have some values, correct? Integer is also numerical, but the only thing is after the decimal point, you cannot have any value, or in other ways, you will not have decimal point itself. It's a whole number, right? 30 or 25 or 100, right? There will be no decimal point. Now, you can put this, but is it possible to put this value to this? Means, can you put the bigger boxes to the smaller box? No, it's not possible. So that's what we are going to understand now. What we are doing here? We had integer x is equals to 30. Fine. We said double is equals to y. Fine. We are saying y is equals to x. So we are putting the smaller box value to the bigger box. Double is bigger. Now you can understand it. Double means something big. Now you are put smaller thing to the bigger thing. Fine, there is no error. Only thing is it will convert it to double automatically. So when I am printing y, the 30 is converted to 30.0. Right? 30 was there in x. I said y is equals to x. X will go to the y. But you know, when it is going into the y will become 30.0. It's not just 30. That's it. There is no other problem here. But is it possible to do its opposite? Let's see. Let's see. So what we will say here, we'll say a value, let's take double. Double r is equals to 56.76. We'll say integer, in the single line I'm writing, let's say integer t is equals to r. Now there is a problem. It's showing me that type mismatch cannot convert from double to int. It's saying that r, which is the 56.76, it's not about the bigger value, it's about the size. Double, even if you have smaller values, the space which it will have is bigger one. Now, coming to this, we are saying there is an integer t and I want to put r into t. It's not possible. It's not possible. You want to fit a bigger bag into the smaller bag, right? So that's the issue. So there are two solutions. Either you make it double, then your program will work. There is no error now. See here. Or you make the r temporarily integer value. The value r is still 56.76, guys. Don't think that r will be changed. It's like take the value of r, convert it to integer, and then put it into the t, right? So if I'll print r and t here, r will be still 56.76. It's not like that you have changed r value. See here, it's printing 56.76. And sorry. Yeah, and t, if you see, it's printing me 56. Why? Because you have converted that 56.76 to 56 and then putting it into the t. So this is called explicit typecasting. Okay. Technical words are different. So let's understand. I'll tell you. This is implicit typecasting. The first example which we saw means typecasting happened, but you don't know, right? Automatically it has happened. You have put x into y will be 30.0. It's not 30. So implicitly it is done. This is explicitly you are doing it. You are converting it explicitly, okay, for some reason. So if you see here, what it is saying, byte value can be stored to short can be stored to char can be stored to integer can be stored to long can be stored to float can be stored to double. It's like this. But opposite is fine, you can store it like this, but then you will lose your basic identity. You'll lose your basic identity. What I'm saying is, as far as value is concerned, it's not like you will be changing it. So the thing is, x was 30. Now you're saying I want to put x value to the y, but y is not 30 now. Y is 30.0. Mathematically, both the things 30 and 30.0 is same. But what I'm saying is, you are changing x just temporarily, not for the whole program, and then putting it to y. It's like this. implicitly it is happening. You didn't do anything here, right? So that is what uh, this is saying, that when you are narrow casting you are doing, you will lose something. So if you see this example, you have 56.76. Now you are explicitly changing it to integer so that it can fit into another integer, right? Now you will lose something. So 56.76 will become 56 actually. Okay, see here. When you have put it into the t is 56. Fine. Going to there are some examples, some theory, understand it, what it's saying. Probably the same thing what we have done here. So what it is saying, that you can put character to the integer. This is something interesting, right? We'll talk about it. We'll talk about it later on. Fine. That's it.